Hi, trigonometric identities. Trigonometric identities is one of the important concept. Algebra में कैसा identities रहता है, like a plus b whole square, a minus b whole square, जैसा एक formulas algebra में रहता है वैसा ही trigonometry में भी formulas है. We call them usually identities. The first identity is the relation between sine and cos. Sine square theta plus cos square theta is equal to 1. This is the first identity formula. Also you should learn how this formula is to be proved. Because we know only the definitions, you just apply the definitions, you will be getting. So from definition to apply the definition, you need a triangle and this is theta. Let us say this is opposite side and this is adjacent side and this is hypotenuse. Now let me take left hand side. Left hand side is sine square theta plus cos square theta. Now sine theta definition. Sine theta definition is opposite side. That means if I write A, B, C, it is equal to opposite side is AB and AC is hypotenuse. So sine square theta, that means you should write AB upon AC whole square. Now cos theta. So cos theta definition is adjacent side upon hypotenuse, that is BC upon hypotenuse AC. So now replace cos square theta with BC by AC. BC upon AC whole square. So then what happened? Square it. So you get AB square upon AC square plus BC square upon AC square. So as the denominator is same, we will add the numerators. So AC square plus BC, AB square plus BC square by AC square. We know that AB square plus BC square, that is sum of squares of two sides, is equal to hypotenuse square. So AC is the hypotenuse. So this is Pythagoras theorem. So now we replace the numerator AB square plus BC square with the AC square. So AC square upon AC square and these two will get cancelled, which is equal to 1. Now we have arrived at right hand side. So this is equal to right hand side. That means we have taken left hand side, we have applied the definitions and finally we got 1. Same way we will go to second identity. The second identity is the relation between tan and secant. This is the second identity. So now, till now we have known only the basic definitions. After this first identity, we got to a formula, that means a sine square theta plus cos square theta is equal to 1. So now we got this formula, we can use this also in this. Okay? To do this, we have only known the basic definitions. But for this, we have one formula is added to the basic definitions, or you can apply the same method. As I have done this method in this, as a practice, you do this using this diagram method. Now I will apply this formula, that first identity. LHS I will be taking 1 plus tan square theta. So what I will do, 1, tan is nothing but sine theta by cos theta. So I will write sine square theta by cos square theta, because tan theta is equal to sine theta upon cos theta. So now I will take the LCM. Then what happened? I get cos square theta as a denominator and it will go here cos square theta plus sine square theta. Now I got this denominator, numerator is nothing but the formula, but the order is changed. In this sin square is first, in this cos square is first. No problem. A square plus b square or b square plus a square are same. Sin square theta plus cos square theta or cos square theta plus sin square theta, both are same. So we replace the numerator with 1 and this cos square theta. So reason is sin square theta plus cos square theta is equal to 1. Now 1 upon cos is nothing but secant. So we can write this secant square theta. Reason 1 upon cos theta is equal to secant theta. So now this is nothing but the right hand side. So this is RHS. So now we have proved second identity also. Now the third identity I will be giving you here. 1 plus cot square theta is equal to cosecant square theta. So this is the relation between cot and cosecant. So this, how to prove it? Either you can use the diagram method or you can use the same method, whatever method. I wish you should do this by yourself. I hope you have understood the three identities of the trigonometry, and how to prove them also you have understood. In my next class, my assistant will tell you the problems depending on these three identities. Otherwise, the applications for these three identities, my assistant Mehak Paryan is going to teach you.
These are the questions related to the trigonometric identities. I will be explaining some of the examples based on the concept of identities. This is the first example which we are going to see. So the question says as if A is an acute angle and tan A is equal to 12 by 5, we have to find all the other trigonometric ratios. So I will first of all write the given part and then further solve the question. It's given value of tan A is given as 12 by 5. So I have to find the other trigonometric ratios. First of all, I will find the values which I can directly find out from the value of tan A. As we know that cot A is the reciprocal function of tan A. So I'll write it as cot A reciprocal function of tan A. So from here I can directly get the value of cot A. So I will put the value in the formula and thus I will obtain the value of cot A. Thus I get the value of cot A as 5 by 12. Further, I know the value of tan A and I can use the second trigonometric identity which says as 1 plus tan square A is equivalent to sec of sec square A. So this is the second trigonometric identity. You must have watched the introduction video in which sir has explained all the trigonometric identities. Kindly refer that first. Then I can put, from here I can get the value of sec square A. So first of all I will put the value of tan A here. So further, here 1 plus 144 upon 25 is equal to sec square A, which I get as 25 plus 144 upon 25 equals to sec square A. 169 upon 25 equals to sec square A. So the value of sec A is obtained from here. Square root of 169 upon 25 is 13 upon 5. So here, as you can see, we have got the value of sec A. Further, I will find the next value. Now I have got the value of sec A. So sec A is reciprocal function of cos A. So I will obtain the value of cos A. Formula of reciprocal function is cos A equals to 1 upon sec A. So you can see that easily we can derive one trigonometric value out of another. 1 upon value of sec A I will substitute. Thus I will get cos A as phi upon 13. Now you can see we have got the value of cot A, sec A and cos A, and tan A is already given. So further we have to find the value of sin A and cosec A. So first I will find the value of sin A, as cosec A is reciprocal function of sin A. So if we find the value of sin A, we will automatically get the value of cosec A, which is nothing but reciprocal of sin A. So sin A, which this is the value which we can obtain as, we can just multiply and divide the value of sin A upon cos A into cos A. We will get the value, we have to find the value of sin A. So we can just multiply and divide, and we can get as sin A equals to tan A into cos A. So here we know the value of tan A as 12 upon 5, and sin A we have to find out, and cos A also value we know, 5 upon 13. So further from here we will get the value of sin A as 12 upon 13. So thus I have also got the value of sin A. Now next I can find the value of cosec A, as cosec A is the reciprocal function of sin A. So I will take as 1 upon sin A. So further I will get as reciprocal of 12 upon 13 is 13 upon 12. So thus these are the required values. We have found out all the trigonometric ratios. This is the required result. In this manner you can solve this question. Now we will solve next question in upcoming. So this is the next question, and here in this question let's see the values what are given and what we need to find out. So the value of tan theta is given as 1 upon root 5, and we have to find the value of this equation. So first of all I will write the given part and try to find the values which are there in the equation, and thus substitute those values and get the required result. So the given part says as tan theta is equals to 1 upon root 5. So further we will use the identity which has value of tan theta. 1 plus tan square theta, as we know, is the second identity, is equals to sec square theta. Thus we will substitute the value of tan square theta here. One plus 1 upon 5 equals to sec square theta. Cross multiply 5 into 1 is 1 plus 1 is 6 upon 5 equals to sec square theta. Now in the result we need the value of sec square theta, so we won't find the square root and just keep the value as it is. Further, so this is sec square theta. Next I will find the value of cosec square theta. So cosec square theta can be found out by the third identity, in which 1 plus cot square theta is equal to cosec square theta. So here I need the value of cot theta. Can we get the value of cot theta from tan theta? Yes, as they are reciprocal functions. So cot theta is equal to 1 upon tan theta. So cot theta will be reciprocal of tan theta. I'll put the value and I'll get as root 5. Reciprocal of 1 upon root 5 is root 5. So cot theta has value root 5. I'll substitute the value in the equation to find the value of cosec square theta, which is the third identity. 1 plus cot square theta is root 5. So I'll get the value of cosec square theta. So here further after solving we get the value of cosec square theta square of root 5 is 5. 1 plus 5 is 6 is equivalent to cosec square theta. So thus I have obtained the value of cosec square theta is 6, and we need only value cosec square theta to find the further value of the equation. I'll put the value in the equation. First of all, you need to write the equation. Therefore, cosec square theta minus sec square theta upon cosec square theta plus sec square theta, which is 6 minus 6 upon 5. Put the value of cosec square theta and sec square theta. We get the further equation as 6 plus 6 upon 5. Cosec square theta has value 6 minus sec square theta is 6 upon 5. Further down here also cosec square theta is 6, sec square theta is 6 upon 5. So further if we solve this, we'll get, I'll solve it here. 5 into 6 is 30. So 30 minus 6 is 24 upon 5, and further in denominator we'll get 5 into 6 is 6. These are simple fractions operations, and 36, which is 30 plus 6, 36 upon 5. Numerator has 24 upon 5, denominator has 36 upon 5. So further cross multiplication, this denominator will go in multiplication in numerator. Reciprocal we'll get as 24 upon 5 into 5 upon 36. So here 5 will get cancelled, and in 12 table 24 is 2 times, 36 is 3 times. Further we obtain the final result. We get the value as 2 by 3. These are the questions related to proving the identities. In this we have to just prove that left hand side is equivalent to right hand side. Here we will be solving two questions. First of all, I'll solve the first question. In this first you have to consider two parts, left hand side and right hand side. I'll first simplify the left hand side. So after simplifying left hand side, we should get it equal as right hand side. See if we get it or not. I'll consider the left hand side, which is cosec theta minus cot theta whole square. So as we know that cosec theta is 1 upon sin theta and cot theta is cos theta upon sin theta. I'll write the values as cosec theta is 1 upon sin theta minus cot theta is sin theta upon cos theta. Cot theta is cos theta upon sin theta. So further just we have to simplify the values and get the result. Here as the numerator is same, denominator is same, we will subtract numerator 1 minus cos theta upon sin theta whole square. We will be separating the squares further for numerator and denominator. We will get here as 1 minus cos theta upon sin theta. Separating the squares we get 1 minus cos theta whole square sin square theta. Here in sin square theta I can use the first identity and put the value of sin square theta as 1 minus cos square theta from the first identity, which is sin square theta plus cos square theta is 1. You can put here it as 1 minus cos square theta. For this you need to know the first identity. I will be substituting the values further. I will get as sin square theta is 1 minus cos square theta. Further you can see that it is in the form of a square minus b square. So a square minus b square has the formula a minus b and a plus b. A minus b and a plus b. I'll be using this here 1 minus cos theta whole square 1 minus cos theta, numerator will remain same, denominator I'll further simplify. 1 minus cos theta, 1 plus cos theta. Here 1 minus cos theta both is present in both numerator and denominator, it will get cancelled, and the remaining value is 1 minus cos theta upon 1 plus cos theta, which is equal to RHS. Thus we get the result for the first identity is proved, LH is equal to RHS. Now we will be solving the second question. Here also first I will consider the left hand side. As both numerators are different, we need to make them same, so we will just cross multiply first. Sin theta into sin theta plus 1 plus cos theta into 1 plus cos theta upon 1 plus cos theta, cross multiply, as it's cross multiplied, 1 plus cos theta into sin theta. Here we'll get as sin square theta plus 1 plus cos theta whole square. Denominator will remain same. I'll further simplify the numerator. Sin square theta plus, I'll put the value of formula, I'll use a formula of a plus b whole square, which is a square 1 square plus twice ab 2 into cos theta plus b square. 1 plus cos theta in denominator will remain same. Sin square theta plus cos square theta is identity, it will be written close. Sin square theta plus cos square theta, and remaining part in numerator will be written as it is, 1 plus cos theta into sin theta. Here as you can see, it is an identity. Sin square theta plus cos square theta is 1 plus 2 cos theta upon 1 plus cos theta and sin theta. 2 plus 2 cos theta and 1 plus cos theta into sin theta. So here you will be able to see that I have gotten the final value. So here 2 we can take common from the numerator, and 1 plus cos theta will be remaining upon 2 upon denominator as 1 plus cos theta and sin theta. So both 1 plus cos theta will get cancelled, and I will get remaining part as 2 sin theta, and which can also be written as 2 cosec theta. Thus we get the RHS. So you will see that you have got the required result, and the value here also LH is equal to RHS. So thus we have proved the following identity. These are some more examples based on the proving the identities. First question is, here also we will consider left hand side, which has left hand side equals to sin theta minus 2 sin cube theta upon 2 cos cube theta. We will see if we get the RHS. Here numerator has sin theta common, so I will take sin theta common. So further in bracket 1 minus 2 sin square theta will be remaining. Denominator has cos theta common. I will take it out from the bracket, and 2 cos square theta minus 1 will remain. Further, here we will further simplify the numerator and put the value of sin square theta as 1 minus cos square theta. Here 1 minus 2 in place of sin square theta, using the identity we can put 1 minus cos square theta. Denominator will be same, 2 cos square theta minus 1. Sin theta, further we'll simplify the numerator. We'll multiply the bracket 2 into 1 minus cos square theta, minus 2 into minus cos square theta is plus 2 cos square theta, upon denominator will be as it is 2 cos square theta minus 1. Here 1 minus 2 is minus 1, so 2 cos square theta minus 1 will remain numerator, sin theta into 2 cos square theta minus 1, and denominator will have cos theta into 2 cos square theta minus 1. Here 2 cos square theta minus 1 is common in both numerator and denominator, so it will get cancelled. Remaining value is sin theta upon cos theta, which is nothing but tan theta. Thus we get RHS. So we have proved the first identity. Now we will consider the second question. We will consider again the left hand side. Here square root of sec square theta plus cosec square theta, we have to prove is it equal to tan theta plus cos theta, cot theta. Here I will use the identities for sec square theta and cosec square theta. The second identity, in which value of sec square theta is 1 plus tan square theta and cosec square theta is 1 plus cot square theta. I will just open the bracket 1 plus tan square theta plus 1 plus cot square theta. Here 2 plus tan square theta will get remaining. Here you can see we can apply the formula of a plus b. If a plus b whole square formula will be applied here, we can take square root out. So 2 into 1 as it is there, nothing, so we will consider 1. So here in the place of 1 we can put tan theta into cot theta, as they are the reciprocal identities. We will write it here 2 tan theta into cot theta plus tan square theta plus cot square theta. Now you can here see we get the formula of a plus b whole square. Tan square theta a square plus 2ab, 2 tan theta cot theta, n plus b square. So here further tan theta plus cot theta whole square will get, and I will take it out of square root and I will get the final result as square root of tan theta plus cot theta whole square is tan theta plus cot theta. This is the right hand side. Now next I am going to solve the third question. Here also I will consider the left hand side. 1 plus square root of 1 plus sin a upon 1 minus sin a. Here we can just multiply the numerator and denominator by 1 plus sin a to rationalize 1 plus sin a upon 1 minus sin a into 1 plus sin a upon 1 plus sin a. You will see here as 1 plus sin a whole square upon square 1 minus sin a into 1 plus sin a is a square minus b square formula, a plus b a minus b, so 1 minus sin square a. I'll take it out of square to take this out of square root. So 1 minus sin square a is cos square a. So I'll just take the values out of square root. 1 plus sin a upon 1 minus sin square a is cos square a. So I'll take it out of square root. So it will be cos a, and we'll separate the values of numerator and denominator for the fraction. 1 upon cos a will get separated and sin a upon cos a will get separated. Thus we will get sec a. 1 upon cos a is reciprocal of sec a, and sin a upon cos a is tan a. Thus we get RHS, and we have proved the identities. Here we will be solving a little bit complicated question. Here also we have to prove the left hand side is equal to right hand side or not. Prove. So we'll simplify the left hand side and see if we get the right hand side. I'll consider the left hand side 2, which is 2 sine to the power 6 theta plus cos to the power 6 theta minus 3 sine to the power 4 theta plus cos to the power 4 theta plus 1. I'll further see. I can apply square theta into cos square theta and cube of these values. A plus b whole cube minus 3ab of a plus b. And further, a square plus b square has a formula. A square plus b square is a plus b whole square minus 2ab. Further, put these formulas and solve the equation 2 of a plus b whole cube. We can get a sine square theta plus cos square theta whole cube minus 3 sine square theta cos square theta and sine square theta plus cos square theta minus, I'll further solve a square plus b square. I'll apply the formula a plus b whole square sine square theta plus cos square theta whole square minus 2 into sine square theta and cos square theta. Here I'll further put the value of sine square theta and cos square theta is nothing but 1. I'll further simplify it 1 cube minus using the identity. Here also sine square theta plus cos square theta is 1. Here also it's 1. Here also it's 1. So I'll further just put the values whichever can be simplified. Minus 3 sine square theta and cos square theta. Here also it's 1 minus 3 into first bracket is completed here. 1 square minus 2 into sine square theta and cos square theta. So here I'll further open the brackets 1 and I'll just multiply also. So 1 cube is 1. So first I'll multiply 2 into 1 is 2 minus 6. 2 into 3 sine square theta and cos square theta is 6 sine square theta and cos square theta minus 3 into just I'm just nothing but opening brackets here, doing nothing else. 3 into 1 square is 1, so 3 into 1 is 1. I am opening the bracket. Minus 3 and minus 2 sine square theta cos square theta is plus 6 cos sine square theta and cos square theta. So here I can see it. Minus 6 and plus 6 will get cancelled. Minus 6 and plus 6 will get cancelled, and sorry, I have forgotten to write this last term, which is 1. So plus 1 and further these values will get cancelled and I'll get as 2 minus 3 is minus 1 plus 1, which is 0. Thus we have got the value of RHS. Thus we can say that left hand side is equivalent to right hand side. These are just some of the practical examples for proving the identities. So I'll consider the first question again. I'm going to consider the left hand side. Here I'll write the left hand side first of all. This is the first step, which is 1 plus tan square upon 1 plus cot square A. So you can see here these are the two identities. This is the second one and this is the third one. So 1 plus tan square A is sec square A and 1 plus cos square A is cosec square A. Here I'll further write it in the form of sin theta and cos theta. Sec square is reciprocal of cos A. So sec is reciprocal of cos A. I can write it as 1 upon cos square A, and cosec square A can be written as 1 upon sin square A. And I'll further just multiply, take the division in the form of multiplication, and I'll take reciprocal of 1 plus sin square A. So I can get the value as sin square A upon cos square A, which is nothing but tan square A. Thus we have got the RHS. This is the first identity is proved. Now I'll solve the second question. Here I'm going to consider the left hand side. This is the first step, that whenever you have to prove the identity, you have to first consider the left hand side and simplify it, and thus obtain the right hand side. This is a standard way of doing it. I'll again consider the left hand side. Sin cube theta plus cos cube theta upon sin theta plus cos theta. Here a cube plus b cube formula will be applied, which is a cube plus b cube is a plus b whole cube minus 3ab of a plus b. So I will apply it. Sin theta plus cos theta whole cube minus 3 sin theta cos theta and sin theta plus cos theta upon sin theta plus cos theta. Here sin theta plus cos theta we can take common. Sin theta plus cos theta, we'll take it common in numerator, and further just sin theta plus cos theta whole square will be remaining, minus 3 sin theta cos theta upon sin theta plus cos theta in denominator. Now here we can cancel sin theta plus cos theta from, as it is present in both numerator and denominator, and just the remaining values we have to simplify that. In numerator we'll get the remaining values, which are sin theta plus cos theta whole square minus, these are the left values. We'll further just simplify it. Sin theta plus cos theta whole square minus 3 sin theta cos theta. Here a plus b whole square formula will be applied. Now also we have not got the value of RHS. We will be further simplifying. Sin square theta plus 2 sin theta cos theta. We will apply the formula of a plus b whole square. Sin theta cos theta plus cos square theta minus 3 sin theta cos theta. So here sin square theta plus cos square theta is 1. I will write it as 1, and remaining value is 2 sin theta cos theta minus 3 sin theta cos theta, which is 1 minus 2 minus 3 is minus 1. So we will get as 1 minus 2 sin theta cos theta, 1 minus just sin theta cos theta. 2 minus 3 is minus 1. So we will get 1 minus sin theta cos theta. Thus this is the RHS. Thus we have proved the identities. In this manner you can easily just prove that. This is a simple question which we are going to solve. Here sec theta tan theta is m, it is given, and if sec theta plus tan theta is m and sec theta minus tan theta is n, so we have to prove that m into n is 1. So I will write the given part, which is sec theta plus tan theta is equal to m, and sec theta minus tan theta is equal to n. This is the given part, and I have to prove m into n is 1. So I will consider the equation as mn is equal to 1. Again I will consider the left hand side, put the values of left hand side and see if I get the right hand side. So I will put the value of m, sec theta plus tan theta, and n as sec theta minus tan theta. So this is formula of a plus b whole square, which a square minus b square, and which is a square minus b square is equal to a minus b and a plus b. So I can write it as sec square theta minus tan square theta. So this is a second identity, which is since 1 plus tan square theta is equal to sec square theta. Next, sec square theta minus tan square theta is equal to 1. Since using this we can get as 1 using the second identity. Thus I have proved the RHS. Left hand side is equal to